Hi and welcome. In this video, we introduce another family of the functions, namely the family of exponential functions. The parent function for this family is y is equal to ex is equal to b to the power x, where b is the base, bigger than 0 and not equal to 1. Let's start with a very simple parent function. Y is equal to 2 to the power x. Remember that 2 is the base, which is bigger than 1. To sketch the graph, we give some values to x and find the corresponding y values, starting from minus to minus 1, 0, 1, and 2, and finding the corresponding y values. Putting these points in two-dimensional space and connecting them, we get the graph of y is equal to 2 to the power x. As you can see, the graph of this function always remains above x. X is therefore the sign is always positive, and this is increasing for all x in the domain. It's obvious that the domain of this function is all real numbers, and the range is starting from 0 and runs up to plus infinity. Next, let's sketch the graph of y is equal to 1 over 2 to the power of x. Remember that b is the base here, 1 over 2, which is less than 1, bigger than 0. Again, we start giving x some values, such as minus 2, minus 1, 0, 1, and 2, and find the corresponding y values. Putting these points on the two-dimensional space and connecting them, we get the graph of y is equal to 1 over 2 to the power x. As you can see, the sign is again positive for all x's and decreasing for all values of x. The takeaway message is that y is equal to b to the power x is positive for all x in the domain and is increasing if b is bigger than 1, such as 2 to the power x here, and decreasing if b is less than 1, bigger than 0, such as the function down here. We can apply all types of transformations to the parent function y is equal to b to the power x. For example, let's start with the parent function y is equal to 3 to the power x expanded by factor 1/2. That means we multiply the function by 1/2, that is 0.5 times 3 to the power x. Let's name this function g of x, and then shift it by 4 units to the right. We get g of x minus 4, which is 0.5 times 3 to the power of x minus 4. And let's name this new function as h of x and shift it downwards by 5 units, that is h of x minus 5, which is 0.5 times 3 to the power x minus 5 minus 5. And let's name this function as p of x. Now let's x reflect the p of x, that is multiplying p of x with minus 1, we get minus 0.5 3 to the power x minus 4 plus 5, because minus minus is plus. Let's name this new function m of x and find the y reflection of m of x, that is m of minus x. Hence, we replace x with minus x here, minus 0.5 times 3 to the power of minus x minus 4 plus 5. And let's name this last function as n of x. The general form of an exponential function is y is equal to e of x is equal to k plus c times b to the power x plus d. The transformations which are present here are very obvious. K is the upward or downward shift depending on whether k is positive or negative. D is the left or right shift depending whether d is positive or negative. C is the shrinking and expansion factor depending on whether c is bigger than 1 or less than 1, bigger than 0. Consider y is equal to minus 3 times 0.5, 1 over 2 to the power x minus 3, and write all transformations. We know that we have a downward shift of 3 units, right shifts of 3 units, and an expansion factor of 0.5. And obviously, since 1 over 2 is less than 1, bigger than 0, this function is decreasing. Next, y is equal to f of x minus 4 plus 3 times 2 to the power of 3x minus 9. This function requires a little bit of algebra in order to be taken into a standard form of exponential functions. For that, we take 3 as a common factor here. We get x minus 3. And then we use this 3 as a separate power, that is minus 4 plus 3 times 2 to the power 3, everything to the power x minus 3. Then minus 4 plus 3 times 2 to the power 3 is 8 to the power x minus 3. This is the child function whose parent function is y is equal to 8 to the power x. Obviously, we can now write all transformations applied to this parent function in order to generate this function. That is a downward shift of 4 units, a right shift of 3 units, and a shrinking factor of 3 units. Consider y is equal to f of x minus 4 plus 3 times 2 to the power 3x minus 1. It sketches its graph and specifies domain and range. We know that after doing some algebra, we get y is equal to 4 plus 3 times 8 to the power x minus 3. We start off with the parent function, which is y is equal to 8 to the power x. That is, this function y is equal to 8 to the power x. Then we shrink it by factor 3. As a result, we get y is equal to 3 times 8 to the power x. Then we shift it 3 units to the right. As a result, we get this green function, which is y is equal to 3 times 8 to the power x minus 3. Now we take this green function and move it 4 units downwards. Moving 4 units downwards, we get this one, which is y is equal to minus 4 plus 3 times 8 to the power of x minus 3. We know that the domain of this function still remains to be all real numbers. The range, however, starts from minus 4, not including minus 4, runs up to plus infinity. Practice for you, consider the following exponential functions, sketch their graph, specify their domain and range, and study their sign. Y is equal to f of x equals to minus 3 minus 4 times 2 to the power x minus 1. Y is equal to g of x is equal to 2 plus 0.5 times x to the power 2x plus 10. Thanks for watching and good learning.